Guys, we're in section 10.5 using parallel and perpendicular lines, page 296. This is going to be very, you'll be doing a lot of computation or calculation, or yeah. This is not too hard on the concepts. It's just kind of tedious. So, in the coordinate plane, two distinct non-vertical lines. Two distinct means separate. Non-vertical means they're not going straight up and down. Are parallel if and only if they have the same slope. Any two vertical lines are parallel. So the slope of one has to equal the slope of the other. And what does that mean? Well, using a generic, let's see. If I had a graph like that, or a coordinate plane, and I said, okay, well, and you name any slope you want. It could be a fraction, could not be a fraction. So don't forget that slope is rise over run. And so let's say I had something like, just for example, 5 over 1. Okay, that means up 5 over 1. So here's what that would look like. Hang on a sec. So up 5 over 1, so you could literally start at any point and be like, oh, okay, well, I'll start right here. And if it goes up 5, 1, 2, 3, 4, 5, and over 1, and this is just me spitballing here, and then I could start anywhere else, like here, and be like, okay, up 5 over 1, up 5, over 1. Then the lines would be parallel. Or if I started over here and been like, okay, well, how about, what if I start right, I don't know, here. And I go up 5. Or you know what, since just the way I drew it, I'll go the other way. So down 5 and to the left 1. Then, like these two lines would be parallel if they have the same slope. So any two lines with the same slope are parallel. That's all it's saying. And for slopes of perpendicular lines, the product of their slopes is 1. So product meaning multiply, is -1. Sorry. The product of their slopes is -1. Horizontal lines are perpendicular to vertical lines, so that should be kind of obvious. Horizontal line perpendicular to a vertical line, exactly. So, so if I drew something like this, and then my vertical line was like askew, then that's not straight up and down, so it doesn't count as a vertical line. So then they're not perpendicular, but this one would be. And then what about like, what about like what about lines that aren't obvious, like, look, like obviously perpendicular, or like maybe you're not sure. Well, then we can use this calculation right here to show that the first slope times the second slope, it doesn't matter which one goes which, is equal to -1. So for instance, let's say I had a line like this, where my slope is 5. Okay. I mean, I know it doesn't look like it, but let's say it's 3 then. We have a slope of 3. So up 3 over 1. Then the other slope, so let's just say this is my first one, then 3 times second slope equals -1. So how do I get the second slope by itself? Well, it's 3 being multiplied, so I would divide by 3. And then I could say, the second slope is -1/3. So that means down 1 over 3. Okay, so I could start anywhere and be like, okay, well, down 1 over 1, 2, 3. Down 1, or let's just go there. Again, this is just like extremely rough sketch. Like, ideally you would have, see, as you can tell, it would look more like this if I was doing it like, if I had drawn out units and made it look really nice. Then I could say, down 1 over 1, 2, 3. It would look similar to this. So that's the calculation. Like you set, if you have one slope, then you just use it as the input for the first slope or the second slope. It doesn't matter, but you just have to divide both sides by the slope to get the other slope. And then like if you have, let's say it was like complicated, you're like, oh, my original slope was -1/3. Like, okay, well, how would I, maybe some of you are just terrible at fractions. You're like, okay, well, -1/3 times second slope equals -1. Okay, and we divide by -1/3. If you are not good at this, like with your fractions, then just use a calculator. So we have -1 divided by -1/3. So here's what that would look like for Google. -1 divided by -1/3. And the parentheses are important because they help distinguish this as a fraction. If you didn't do that, and here's the answer. -1 divided by -1/3 is, oh, it's 3. Oh, well, we already did that. We knew that. But let's say you didn't do that, or you didn't have your correct appropriate parentheses, then you would get +1/3, which is just flat out wrong. So whether you're doing this in your calculator or doing it on Google Calculator, make sure you have parentheses. Or if you don't want to use parentheses at all, but you do know that -1/3 is -0.3333, then you could go, oh, -1 divided by -0.33333. Like, oh, look, it's 3, right? And then obviously you have to round because this was only an approximation. So you'd have to round and be like, oh, it's 3. So slopes of perpendicular lines, multiply together to make -1, and there it is. For a short, well, let's do one more just in case. So let's say I had y equals, I don't know, 2/5 x minus 6. Well, the slope is the 2/5 part. So m equals, so I can literally just ignore the -6. Y equals 2/5. And then to find the other slope, I'll say, okay, well, 2/5 times second slope equals -1. So I'm going to divide both sides by 2/5. So again, using Google, I can say -1 divided by 2/5, and I will get -0.4, which is not right. Let's see. Oh, I didn't even have the negative sign. -1 divided by 2/5 is -2.5. So I could say, oh, the second slope is -2.5. But if you're a fraction person, then -1 divided by 2/5 is the same thing as multiplying by the reciprocal. So -1 times 5/2 is -5/2. So a shortcut is, if you have a slope, then the slope of the perpendicular line is the negative reciprocal. So if it's positive, it turns a negative, and then you take the reciprocal of the fraction. So instead of 2/5, it's 5/2. If it was already negative like it is here, then you would make it a positive, and then instead of 5/2, it would be 2/5. That's a simple shortcut for slopes of perpendicular lines or perpendicular slopes. Okay, find the distance from point A to the given line. So the shortest way to get something, to get from a point to anywhere else, is a straight line, a straight perpendicular line. So we're like, okay, like, is that this, or is that like this? Well, the answer is neither. I have to have a perpendicular line, which means I have to use the slope. So m is -2. Then I have to use a perpendicular slope. So using the, what's shorter? Oh, well, this is shorter than those two, but that's not necessarily, well, that could, but we don't know. So if I'm just spitballing, it'll look probably like this. But let's see, we don't know. Or I don't know without like calculating in particular. So I could say I have to use the perpendicular slopes. Be like, okay, well, -2 times the perpendicular slope is -1. Or I can use my shortcut and be like, oh, well, instead of negative, it's going to be positive. And then if instead of 2 over 1, it's going to be 1/2. So I know I'm going to have a slope of positive 1/2. So I could say y equals 1/2 x plus b. And it has to go through 4, 5. And it also has to go through this line at some point. So I could just honestly just start here and be like, and work backwards. So I know from here to there, it's going to be up 1 over 2. So I can go backwards and go down 1 over 2, down 1 over 2, down 1 over 2. And let's see if I did that right. Up 1 over 2, up 1 over 2, up 1 over 2. Okay. You're like, well, like before I can calculate, I need to know what this point is, right? Like, oh, well, how can I do that? Well, let's see. This is a variety of ways we can do this. First, we can see that the point of intersection is, or sorry, the, what is it called? The y-intercept is 3. So I could say y equals 1/2 x plus 3. But I know it has to connect with this line, which is -2x. If they connect or they're intersecting at the same spot, then they're equal to each other. So I could say -2x equals 1/2 x plus 3. And then if you solve it, then you will get the x value. And then once you get the x value, well, I'll just show you. So subtract 1/2 x, subtract 1/2 x, -2.5x equals 3. So to get x, I will go ahead and take 3 and divide it by -2.5. 3 divided by -2.5. I get -1.2. So right here, -1.2 is the x. And then I can plug it into either equation, this one or this one, to get y. So I'll say y equals -2 times -1.2, which is, sorry, -2 times -1.2 is positive 2.4. And then you use the distance formula between these 2 points. So like I said, pretty calculation heavy. And if you're not sure, literally just rewind and rewatch exactly how I did that, because as you can tell, it's a pretty lengthy process. Yeah, let's see. Here, the same exact problems, but you don't have drawings. So, okay, y, the slope is -3. And then to find the other slope, then you could say, oh, -3 times something, the second slope, is equal to -1, divide both sides by -3. Or you can take a shortcut and be like, oh, well, instead of -3, it's going to be positive instead of negative. Second slope is going to be positive instead of negative. And then 3 as a fraction is 3 over 1. So I'm going to change that to 1/3. So I have y equals 1/3 x plus b. And to find b, there I had a picture, but here I don't. So we know that the point passes through 0, 5. So I can plug it in, 0, 5, right here, plus b. So I have 1/3 times 0, which is 0. So 5 equals b. And then I have this, y equals 1/3 x plus 5. And I could do what I did before, which if you're not sure what I did before, literally just rewind it. The lines have to be equal to each other because they intersect at a point. And to find that point, you'd say negative 3x minus 5 equals 1/3 x minus 5. You solve for x here. You plug it into either equation. After you find x, you plug it into either equation to find y. After you have an x and a y, then you use the distance formula between that spot and here to find the distance. And then, I'm just standing by, so let me know if you have any questions on that.